Welcome, student. This is a online video solution for the science and technology round 1. Okay. Now let's start. Very important. Okay. Now, importantly, we having a question paper as well as the answer paper. Now, without wasting time, let's move to the question number 1. Solve the following questions. First question, name the metal to which alkali metal, important, name the group, you have to name the group to which alkali metals belong. So of course, alkali metal belong to which group? They belong to the group first A, and the names are lithium, sodium, potassium, rubidium, cesium, francium. Okay, these are the elements called as alkali metals. Okay, now it is very easy and it belongs to the group first A. Okay, now the name halogen to which group they belong. Halogen, आपको halogen का name बताना है. What is the name of halogen? और वो किस group से belong करते हैं? That you have to explain. The halogens are named are fluorine, chlorine, bromine, iodine, and astatine. Sometimes astatine is a short-lived radioactive elements. So sometimes it may not be considered as a group element of the halogen family. The element belong to the 7th A of Mendele's periodic table, and in the modern periodic table, 17th group. It is 7th A of Mendele's periodic table and 17th of modern periodic table. Now it is very easy. Now let's move to the next question called as question oxygen and sulfur, whose atomic number is given, belong to the same group of periodic table. On what basis? Electronic configuration. On the basis of electronic configuration, you have to identify the group and period to which they belong. Okay, it is very important. Now, you already know the number of group or number of shell, what it actually defines. You know, the number of electron in the outermost shell, it defines a group number. And when we say the number of orbits, it always represents a period number. Now, let's read out. Group number indicates the number of valence electron. Group number indicate the number of valence electron. Means whatever the number of electrons in the outermost shell, that is valence shell, it will be the group number. For example, electronic configuration of oxygen is 2,6, where 6 electron is called as valence electron because it is present in the outermost orbit. So it belongs to the group 6th A. Simple. 6 electron in the outermost orbit, so belongs to the 6th A. Okay. And second period. Why is it so? It belongs from the second period because it is having 2 orbits. First orbit 2 electron, second orbit 6 electron. You must be getting this. Now, quickly move to the next. Sulfur atomic number 16, electronic configuration is 2,8,6. So it belongs to the group number. This is what group number. Valence electron represents the group number. So 6A is a group number, and as it is having first cell, second cell, and third cell, of course, it is a period number, third period. Okay, it is very simple, my dear student. Always remember this: the number of valence electron, that is outermost orbit, always represent a group number, and the number of orbit, that is the first cell, second cell, third cell, they always represent the period number. Okay, now this is very interesting and easy question. Correlated. Newland's octaves. When we talk about Newland octaves, we always talk about the number of elements which is arranged in the in the sa re ga ma pa da ni sa sequence. So when we talk about Newland, we talk about octaves. When we talk about triads, we always talk about the Dobereiner. Means triad is given by Dobereiner, and the octaves, the law of octaves, is given by the Newland. What was the law of octaves? When elements are arranged in increasing order of their atomic masses, he found that the properties of 8 elements are similar that of the first element. That was the law of Newland Octaves. And what was the open-ended triads? When elements are arranged in increasing order of their atomic is approximately equal to the arithmetic mean of other two elements. That was the open-ended triad. So very easy relation. Now let's find out the odd man out. So the electron, proton, and neutron are the subatomic particles. Of course, we know that these are inside the atom. Okay. Now, when we see the lanthanide, lanthanide is an element, or lanthanide there is a series. So it is an element, and these are the subatomic particles. So you can take it as odd. So lanthanide become odd. So lanthanide and others are subatomic particles. So it was very easy. Now move to the question number 2. It carries 4 marks. So state and explain Mendeleev's periodic law. State and explain Mendeleev's periodic law. When elements are arranged in increasing order of their atomic masses, Mendeleev found that element with the similar chemical properties repeated after definite interval. So that becomes the law. Let me explain in a simple word. What is Mendeleev's law? Actually, he explained everything in the form of what? In the form of what? In the form of what? In the form of atomic mass number. Atomic mass number. When we talk about atomic mass number, of course, so he said whatever the atomic mass number, it is directly depend on the whether they having some physical properties and chemical properties. And he said the physical and chemical property of an element are depend on the atomic mass number. So that was the law of Mendeleev's. So you can say physical and chemical property of an element are the periodic function of their atomic masses. That was the law given by the Mendeleev's. What was the law? Let me repeat. Physical and chemical properties of an element are the periodic function of their atomic masses. The important word called as masses. You have to remember. So similarly, when we arrange the element in increasing order of their atomic masses, what we observe is they having the physical property, they having chemical property are just what are similar. They show some regularity. That was Mendeleev's periodic law. It was very easy actually. Now, this is one of the easy question and tricky question. So, importantly, this is the periodic table. You can take beryllium, yes, any element. So, and you have to give the configuration of electronic configuration of any one element. The lithium atomic number is 3. So electronic configuration 2, 1. It is print mistake. So you will say 2, 1. Electronic configuration is 2, 1. Always remember electronic configuration is 2, 1. You can take beryllium, you can take hydrogen, or you can take anything. So that is very important. Now identify the block. This for B. Identify the block. It is which block? A D block. And period number is 1, 2, 3. And this is fourth period. It was very easy question, but important one. Always remember. Now, quickly move to the next question, which is called as demerits of Mendeleev's periodic table. And it is very important, my dear student. Demerits of Mendeleev's periodic table is one of the important questions for everyone. It is every time favorite question. Okay, all time favorite question. So hydrogen, first, there was no fixed position for hydrogen. Hydrogen could be placed in the halogen, as it shows the property of non-metals, but it could be placed in the metal as well, because it having the 1 electron in the outermost orbit. That is the property of metal, less than 4 electrons. So there was big ambiguity in the position of hydrogen. So that was demerits of Mendeleev's periodic table. There was no fixed position. Yes, the isotopes of element having different masses, and as they having different masses, and he arranged the element according to increasing order of their atomic masses. So isotopes could be placed at different position. As he said, I am arranging the element according to increasing order of their atomic masses. So as he is saying, if elements are arranged according to increasing order of atomic masses, so there must be 2 carbon, because carbon 14 and carbon 12 having different masses. So carbon should be placed at different position, and next carbon should be placed at different position. But what we observe, It is absolutely wrong. And what we observe, carbon is at single place. So this is ambiguity. So as they having different masses, they could be placed at different position according to his theory, but they are at same position. So that was the mistake. Isotopes of element having different atomic masses, therefore they should be given different position, but they are at same position. Yes. Now other points are there also. Very very important points. So that let's see the important point. So some elements like cobalt and nickel having different atomic masses. So the element having lower atomic mass are placed after higher atomic mass, means the higher atomic masses element are placed before the lower atomic mass. For example, cobalt and nickel. If you see cobalt having 58.93 and nickel is 58.71. So the cobalt is placed before nickel. It was ambiguity. So the element having higher atomic masses are placed before the lower atomic masses. So that was the mistake. Now some element are placed in the group where the properties are not matching. The element are placed in the group where properties not matching. For example, manganese is placed in the halogen where the properties are very different, because manganese is a kind of metal and halogen are a kind of non-metal. So you can say the manganese is placed in the halogen. It was the one of the biggest mistake. Means element belong, as we say, element belonging from same group, same property, but there was mistake. Okay, now that is important. Okay, now let's do the thing. Okay, next question number 3. Okay, now importantly, element having electronic configuration 2,8,8,2, which you have to comment about the atomic number. So that just do the summation. That would be very simple. And group of element, that would be the last element. Okay, now the period, the number of shell. So atomic addition is 20, 8 plus 2, 10, 10 plus 10, 20. And group second, because last number is second. So group is second. Fourth period, why? Number of shell, 1, 2, 3, 4. So fourth period. Okay, it would be fine. So now the question number 2, write the name from description. Atom having smallest size, it is hydrogen. Sometimes you may get the like ambiguity whether it is helium or it is hydrogen. But what I think is, I referred from the different references and I observed hydrogen is a correct answer for the smallest size. Sometimes most of the people internet says where we say about helium, but believe me, hydrogen is the smallest one. Now the atomic mass smallest, hydrogen. Okay, now most electronegative atom is fluorine. Remember this, most electronegative atom is fluorine. Okay, now explain the term periodic properties and explain the following trend with the periodic table: valency, metallic character, and atomic size. Valency is a combining capacity of an element. It is determined from the number of electron in the outermost shell. Yes, when elements having less than 4 electron in the outermost shell, they always what? Lose the electron. When elements having greater than 4 electron in the outermost shell, they always accept the electron. When elements having equal 4 electron in the outermost orbit, they always share the electron. That is what the valency that we see. So the valency varies in the periodic table. How it varies? It varies from like left to right and top to bottom. So that we have to see. So therefore, the valency always vary, and always remember along the group, valencies always remain same. When you talk about one group, the valency is always same because element belong from same group has same outer electronic configuration. As they having same outer electronic configuration, they show a same valency. That is what important. The metallic character, you have to comment on metallic character. The metallic character is a thing. When we say metal having metallic character, means they having tendency of losing the electron from the outermost orbit and form a positive ion. That is what a metallic character. So when we move left side to right side in the modern periodic table, the metallic character goes on decreasing. That is what very important. Non-metallic character is exact opposite of metallic character. The metallic character is losing tendency, This non-losing tendency is non-metallic character. Yes, that is increases from the left to right. Atomic size, that atomic size is defined by the atomic radius. So atomic radius is the distance from the center of atom to the outermost orbit. So atomic radius, it's always define the atomic size. More the radius, more the atomic size. So when we move left to right, the atomic size decreases, but when we move top to bottom, atomic size goes on increasing. So this is the representation like this. When we do move like this, so left to right, the atomic size decreases, but when we move top to bottom, so atomic size goes on increasing. So this was the short explanation for the question paper, and I think the paper was very easy. Okay, and thank you.